Good morning, class. We have just started with the second part of this our tool engineering course, that is related to the rolling of metals, forging of metals, and other related the models related to the sheet metal working operations. So today we will start with the module number 5, that is the forging of metals. Basically, the forging of metals, I think you must be familiar with the forged parts. I think you must have seen the different spanners that is used for the handling the fasteners, for tightening, loosening them. Then some of the tools, that is also forged one, that is basically used. The forging process is basically used for managing the critical components where the strength requirement is critical one. So today we will start with this process. So let's see further. If you've seen in the figure A, B and C, the three figures are shown. One is related to the first product is made by the casting, in which all the grains are having the isotropic properties. The second figure is B, where the grain lines are disrupted. Grain lines are disrupted over here. Okay, so that will hampering its strength. Here the properties are having the isotropic properties of the grains are there, but the grain lines are not disrupted, but it may have some difficulty. It is only having the compressive strength rather than the other strength criterias. But if you want to have the better properties compared to the casted component or the machined component, you must have to go for the forging process. In the forging process, basically we will get the component of this shape, of this, not the shape, but basically the if you manufacture the component of this kind of shape, because of the forging, the metal grains are flowing like this around the sections, and they are having the continuity. So basically, because of their continuity, they are offering the more strength. Now here basically there are different forging processes are there, cold forging process and the hot forging process. Basically we will see that further. But what is the metal flow in the die and the metal grain structure can be controlled. The metal flow in the die and the materials grain structures can be controlled in the forged part, so that it will produce the strength, good strength and the toughness, which is very reliably used for the stressed condition and the critical applications. Basically here also the two dies are there, and in between which we will first keep the blank. Then based on our requirement, we may heat the workpiece, or we will heat the die, or we will heat both of them, or we cannot heat both of them, and we will just do the process. So and so that the metal is first flow in the die. Because of its metal flow, the kind of behavior of the metal flow in the metal die, the grain structure will flow in the particular direction and they will attain the particular structure. Here it is not, we are not performing the forging at the recrystallization temperature of the metal. What does it mean? The grain structure will remain same, but only its structure, grain structure will remain same, and its widths will remain the continuity only. In you must have seen in this point number 2, the cold forging required the higher forces must be, definitely it will require the, because it is not possessing sufficient ductility at the room temperature, and also the temperature to undergo necessary deformation without cracking. So the then in the hot forging, the lower forces will be required, and the accuracy and the surface finish of the part is not good as that of the cold forging. It is the same related to the our rolling of metals, the same kind of criteria are there. Further, there are different types of die forgings are there. Basically, this die forging is of different types. One is a upsetting die forging, means whenever we are performing the forging of the metal in the open environment, so it is called open die forging. If you see the figure number A, B and C, it shows a process in which how we can perform the upsetting or the flat die forging. The name itself suggests you the dies we are using that are flats in nature, okay, and the alternate name is for the upsetting die forging. Just remember this name. This is just you must be familiar with this terminology when you will go through the problems. Okay, so in the figure A, initially the height on the workpiece diameter is given. Height and the diameter of the workpiece is given. Then in the figure B, when the driving die pushes the workpiece, it will change its height and diameter. It will change its height and the diameter. Okay, so because it is changing its height and the diameter, so it will be regarded as a instantaneous height and the diameter. It will be very important parameter when we will going to study the behavior of the metal as the pressure comes over the workpiece. Okay, and at the last you will see the barrel like structure is formed, means the diameter is new, height is new, and the barrel like structure is formed. Now here the different cases are there. Okay, so it is basically the upsetting die forging process is there. Okay, now in the uniform deformation, the workpiece under the frictionless condition, means there is no friction is there, means it's a fictitious process, ideal process. Because of the constancy of volume maintained, any reduction in the height increases the diameter of the forged part. Means in this case, you will not get the figure like C. No barreling is there in the uniform deformation process. Then second is a pancaking deformation in actual operation, means in real practices. There is a friction and the part develops the barrel shape. Okay, this kind of shape in the actual practices. Why it is happening? If you see here, the friction forces, the directions are given. There are the friction forces. Why this direction is given like this in the inward direction? Because the workpiece interface over the die surface and the workpiece interface, they try to move out because of these forces. To maintain the constancy of constant volume, this workpiece surface try to move out, but in real condition, because of the friction, their outward movement is being restricted at these interfaces only, here and here. These are in these interfaces, which will create more resistance to the flow of metal in the outward direction. As its direction of flow is in this direction, therefore the friction will be this direction. Similarly here also the workpiece is moving like this, therefore the friction direction will be like this. Okay, and now they will definitely see some path of the very minimum barrier. So here the structure will be formed here like a barreling. Okay, barrel structure means here the less resistance is there. That's why the workpiece material try to move in this open zone outside and form the barrel structure. Definitely it is a solid one. That's why it is not create some like discrete parts. Okay, so it is a pancaking deformation. This figure relates to that. So here, okay, it is now the forging force is important to calculate, because we are dealing with the different types of material. As the new application comes, the new material has to be evolved, and the material properties you should know, because if you want to forge it. Okay, so for that, basically this forging force depends on so many different parameters like material strength, then the working conditions of the process, then the properties material properties. So these are the key factors. There are the three key factors for deciding the what will be the forging force. The die design definitely depend on the kind of workpiece material product design that we are dealing with. Okay, so the forging force is directly proportional to the flow stress of material into pi into r square. So what this term actually defines you, as you are applying the force over the cross section, okay, multiply by this stress factor, that will become your force. But here one additional term we are adding here, that is a constant or the cofactor 1 plus twice 2 times mu, coefficient of friction between the workpiece and the die interface, into r into nh. R and h, it's a instantaneous values of the that workpiece radius and height. What you can imply from this, basically, as this r and h changes, means it is a set r1 h1 r2 h2 r3 h3. So for these different sets of conditions, you will get the different values of force experienced by the die. So that will be useful now when they will get the maximum value. That will be useful for designing the die material, for selection of die material, as well as for selection of the press. Okay, press that is required for forging the component. Okay, next slide. The next is the impression die and the closed die forging process. Now this figure number 14.5 will be repeated in the last part, that I will give its design consideration study in very briefly. Okay, but in the impression die forging and the closed die forging, these are the two different processes. The basic difference between them is, in the impression die forging, refer the figure number 14.5. Here the two dies are there. One is a bottom die, it's a top die. This blue color part is a workpiece material. Okay, now see the design of this die properly, and see the design of this closed die forging. It's a closed die forging process, and it's a impression die forging process. If you see in the impression die forging process, the difference between this closed die forging process and this impression die forging process and their setup, the difference is that the getter is provided, that is like an open portion that will just allow the flow of extra flash, that is provided in the impression dies over the closed dies. So definitely question will come to your mind, okay, that there's so many different questions are there, like what are the volume of material we are considering over here, that will have more is we can have the freedom to choose the volume of material in particular tolerance. Here we don't have any freedom of tolerance. We should have to choose a very accurate volume of material for the closed die forging. Here basically the steps are given. The blank to be forged is prepared. Okay, this pre-preparation is done. Then cropping from the axle means here the figure 14.6 is given, which shows you the die inserts used in forging of an automobile axle housing. I think you must be familiar with the automobile axle housing. So their die materials are given. Upper die material is given 6G or 6F2. Lower die, this will be the lower die, this will be lower die, it will be the upper die. Now this will be the upper die insert, it will be the lower die insert. Both are made of the H12 material. And this blue colored it is a workpiece material. You don't find here any open space like getter. Okay, and here the pins are provided for ejection of this component. Okay, here the steps are given for the closed die forging, cropping. After that, after the component get forged, cropping from the extruded or the drawn bar, then preforming operation such as powder metallurgy. Okay, so like this, these are the different ways by which we can make this axle housing part. Okay, the next part is a preforming operations. In preforming operations, basically, as you seen in this figure, okay, it is like it is used to distribute the material properly into the various regions of the blank using the simple shape dies of various contours. Means simply if we have a particular shape of like this, let's say, okay, so we can make its first blank drawing like this. So this is our raw material. So first I will make it to roughly to this size, not exactly but roughly to this size like this. So it is called as a aging process. In aging process, there are two different types of process are there. Aging means the central part will become thicker and exterior part will become the thinner, and on the contrary, the fulling process is there. Fulling, in this the central part will become thin and external part, outer part will become thick. So here you can see the fulling and the aging process both are used in this. Aging and the fulling process are used, and because of which we can get the part in the step 2. The third process is the blocking process. Blocking means simply it is like a forging process. Is the forged die will come, we have to keep this part in the forging die, then we will have to apply the forging force in the particular design die, then further it will get finished to this size by removing some of its. Yes, it is not like from here you will get directly the product. We'll have to remove the unwanted parts in the steps without hampering the quality of the workpiece, and finally you will get the, after trimming you will get the final part like this. Okay, blocking is generally performed using the blocker dies. Means specific dies are there, like the same thing, the forging dies. Okay, and the flash will be removed by the trimming operation. So so the trimmer machines are used for removing this external flash. That is where it is generated. Basically it is generally generated at the parting line of the dies. Okay, as same in case of the casting process, metal casting process. Now here it is a impression die forging process is there, that we will see in very deep now. Workpiece takes the shape of the die cavity. Workpiece take the shapes of the die cavity while beginning the first between the shape dies. Process is carried out at the elevated temperature to lower the required forces and enhance the ductility of material. So generally at elevated temperature, further slides there is a data table is given related to the forging temperature of metal. What is the range of the particular kind of metal at which we can forge them very efficiently. Now during the deformation, some of the material flows outward in the form of flash, like this one. Okay, so high pressure and the resulting high frictional resistance in the flash presents the severe constraint on the outward flow of the material in the die. Now what is basically happening here, whenever we are applying the force over here, this material tries to flow outward, will get resisted because of this first edge, second edge, and further. Now our aim is finally we will have to get this shape. This is our first aim. We will get this shape after the material will itself experience some resistance. But after filling the entire cavity, the workpiece should experience the internal high stresses, because if suppose some intricate features or the design is there here or here, like sculpture, like particular sculptured design is there over this surface. So there the filling of metal will become very difficult. It will become difficult when the pressure inside this workpiece in the forced condition or in the last stage is less. So but if we have the higher pressure or the forces experienced in the workpiece itself in this condition, so what are the miniature sculptured part is there, the sculptured design, as in you can see in the coins also, that can be easily, where the metal can be easily filled. So for creating the high pressure over here, we can go for the impression die forging. And in the impression die forging, the particular design is there, like this is like some surface is there here, some length of surface is there, this one and this one. So where the workpiece metal will flow outside, and when it is flowing outside, it will get resisted by this surface and this surface. So because of which it will get stopped or stuck over there, and after it gets stuck, it generates the pressure inside, and we will get the very fine detailed structure on the final product. Okay, now this design also, the length of this surface, this area of this surface, and the gutter design, that is also very important. That will, the design part, that will come with the experience. Okay, now here the forging force is given in case of the impression die forging process. Force equal to K times, it's a multiplying factor obtained from table number 14.2 for simple shapes without flash. Okay, means simple shape is there and the flash is not there, so K will be 3 to 5. Simple step with the flash means this will be our condition. Now case number, this will be the case, so K will be 5 to 8. For the complex shape with flash, means complex shape means where the parting line is not lying in the more in one plane, it will lie in more than one plane. Okay, so for that the K will be 8 to 12. If is the flow stress, the same thing. The flow stress means the when the grains are flowing, so at that time they will experience some stress as a flowing condition, and the A is the area, projected area of the forging. That is generally taken, the projected area is taken generally the area of the parting line of the die. Okay, the next figure will show you, this will be the A figure is it is one of the figure that will give the idea about the impression die forging process. In the impression die forging process, you will have this kind of die design, this will be kind of the billet, and this will be the kind of the product, and it will be the flash. And here in the closed die forging process, you will see entire volume of this billet material is used for making the same kind of edge kind of axle housing. For making the same kind of edge kind of axle housing, the complete material is used. There is no excess material or the wastage of material is there. But the volume consideration and the calculation of volume is very important. When you are going to calculate that volume, you will have to consider the temperature of the workpiece material, thermal coefficient of expansion, temperature of the workpiece material, and the related to the dies. Okay, so in the closed die forging process, the true closed die forging process, the flash does not form and workpiece completely fills the cavity. In this forging process, it is very high and accurately controlled blank volume, and the proper die design is essential. Proper die design is essential because there is no scope to accommodate the extra pressure, means we don't have any flexibility to control the pressure inside the die by changing the gutter volume and that land. Okay, to produce the forging with desired dimensional tolerances. If the undersized blank is there, it will not allow the complete filling of the die cavity, and oversized blank means the very excessive pressure that will cause a premature failure of the machine to jam. Thank you.